this video we move to the fifth subchapter of this chapter 3, talking about the statistics, and we will discuss about how to calculate the correlation between two data sets. Within this chapter, we may not need to draw the plot. That will be the next subchapter to do. It's called scatter. The plot is a new type of the chart we will learn. For this chapter, as the preparation is we focus on the mathematical part and also try to implement our function that we can be prepared to draw those scatter plots. So let's start. By the way, today is weekend, and you can see behind me is a very nice sunshine. So it's not. It's the good time is for us to do the study. Let's see. So, and here, if you go to the GitHub, doing math with Python, you can see the latest code had already be added until the number 4 subchapter. So all the code we used in the demo, we practice together to ensure they are runnable. So if you want to practice using those reference codes, you can clone the repository, or you can fork them to your own. And you can start to modify based on your purpose. That will be the easier way for you. But still, as I emphasize many times, is you can learn from copy paste, but the best learning is you refer to those code and you do the ensure you do even the typing yourself. So you can also find this from my demo. Is sometimes I have some typo errors, then that will pop up some mistake or the error message. That also are learning curve. You will familiar is how to do the troubleshooting, how to do the debug. So try to practice yourself and try to get the knowledge along with my video, and then this accumulate to your mathematical skills. So correlation. So first of all, is this is the new the mathematical concept talking about our two data set relationship. So calculate this correlation. We will call that is the Pearson correlation coefficient to describe the nature and the strength of the relationship. So if you only have one data set, you can calculate the sum of the result like a summary or means, the medians, and we have also the range, the static, the deviation, variance. So we learned that in the past sets, but that's for the single data sets. If you have two data sets or more data sets, another dimension we want to understand is the relationship. So if you learned my other video sites about the knowledge graph or the ontology, so relation actually is more and more important, the concept or context when you're talking something. So you can build entity, different entity, but what's those relationship between those entity? If we come to the mathematical, those entities can be list of the numbers. We call that the data sets. What's the relationship of them? How you can describe those relationship? That will be important for you to, for example, to do the forecast or to do the machine learnings, those the rules or the patterns. So without those understandings, we are not able to tell more this intelligent way of those multiple the data, especially big data. So the coefficient can be either positive or negative, and its magnitude can range between -1 till 1. including -1 and -1. So if our coefficient is go to the 1 or closer to 1, we will see these two data sets has a strong positive linear correlation. If it's reached to -1 or close to -1, we will see they are strong negative correlation. So, but we also need to distinguish correlation and causation. So here is a paragraph I would like that you can read in more detail. Is correlation. The key statement is correlation doesn't imply causation. So our famous sample is within the city, the sales of the ice cream, and the rate of the crime. You may see if you just have these two data sets, looks like they have quite a strong positive correlation. But it does means the increased crime sales will increase the crime rates or vice versa. So that is kind of are misleading. Those conclusions because they may all both caused by the increase of the weather's temperature. So, but it's just the weather's temperature will be the causation is also difficult to judge. So, if you want to analyze something and you learn after you calculate, you learned some relationship from the correlation. Try to make those correlation back to the practical scenario and to understand whether there's other data sets you should also consider. So when you have more data sets, actually if we treat those data sets as those elements and you give them property and you analyze their relationship, actually you are moving into the knowledge graph. The field. So that will be more exciting one, but you can see here the fundamental, the concept or the method is coming from this statistical, the calculation. And then the formula is quite direct. So just you don't need to memorize that or remember this in detail. Just you can try to understand the logic. So the correlation is just something divided by another part. Is first is this sum of the product of the individual element of the two data sets. So you make them is the product, the multiply, and then times the numbers of this data. The implied the assumption is that these two data sets has the same total number of the data. So if they don't have one data set has a 3 data number, another is have 5 number, it is not make sense you talk about what's the correlation for the second sites, so number 4 and the number 5, because there's no matching in the first the data set. So by assumption, so we assume they have the same the number of the data sets. So we have a single n. But what if you have these two different numbers of the elements in two data sets? This calculation will end to the data sets which have a lower total number of the elements. They will ignore the rest of the longer numbers in another data set, so that they still have the paired calculation. So every is the pair. That from this sigma xy means the x in the data set x, data set y. So you will have x1 times y1, and x2 times 1, y2, x3 times y3, xn times yn, extra, and then you make them summary. So that is the grand total. So using the similar way, you have this sigma x, sigma y, and here is the minus, and divided by our square root. Here is the sigma. First is the x squares. And then here is the difference is n times sigma x squares first, and then minus sigma x first, then do this square. That is the first part and second part is the second. The data size is the same, and make them multiply each other, then give our the square roots and put that into as the dividend. So that is the correlation. So with this formula in mind, is if we got input of two data sets, we can just one by one to calculate every components and make them combined, and then finally we have our the divided this operation, and that is our this calculation. So I already put this simple sample. So we will introduce the zip function. So zip function is a useful function when you deal with two data sets. So if you have one data set, let's just a short name like list 1, 1, 1, 2, 3, list 2, 4, 5, 6. So both this data set has a 3 number. If you make the length like it's a len list 1, 3, len list 2, 3. So we have this one. And then this 4, because if you want to do something for these two data sets altogether, and you want to make them have the related operation one by one, so we will use this zip. So if you put list 1, list 2 as the zip functions variable, then when you print that, they will print that in pair. So that means they make them as a pair per pair. Is 1 link with 4, 2 link with 5, 3 link with 6. Then that is the print. If you change this print to our operation, so like I want to calculate the multiply, so you just do this one, and they will do also the pair by pair. So first x times first 2 y, for second x times second y. So you get is 1 times 4 go to 4, 2 times 5 go 10, 3 times 6 go to 18. So that is the this kind of the zips function. But what if let's see? So I rename is 4, 5, 6, 7. So now if I do this and print x times y, you can see the number 4 in this means this number 4 element in list 2 is get ignored. So that is the thing is with let's see, I think by hand, and here the author mentioned this in somewhere. So I remember putting that here. You're combining them, and in the moment we write this, and z function return. Yeah, so here, if the two lists are unequal in length, the function terminates when all the elements of the smaller list have been read. So remember this carefully, because it may give you some the misleading results. So if you don't understand this calculation logic, so try to give the inputs to zip function with two equally length data sets. If you don't remember, is some data in this longer the length data size may be ignored. Or will be ignored, not may. So that will be this nature for the zip function. So once we have that, is for this video is we will do more. Actually, is just the mathematical calculation. So let's create our function. So and we later on will use this function to do the correlation calculation. So let's create a new one. So I copy the header and create this 3, 5, 1. finding correlation.py. So we have this find correlation. This 17. So let's do this demo here. So if you see that, I will see the first. Let's see our definition will be the find correlation from data set X and the data set Y. So we get two inputs. So that is our the data size, and n equal to length X, because we have the assumption is XY has the same length. And then let's see. So let's make our min function. So the X equal to 1, 2, 3, 1, 2, 3, and Y equal to, let's not give a 4, 6, 5. Maybe that is quite correlated. So let's give it 4, 8, 2 as or maybe give more data. So 6, 4, 5, 3. So then what we will do is print this correlation. So find correlation and XY. So we will have this if I run that, nothing, because I doesn't have anything. So return correlation. Then let's define those. So when we make the calculation, let's keep this step by step here. So first is find, let's do this. Find the sum of the product. So let's call this product in empty. Then we starting from this one, sigma x times y. So that is just the one, the step by step for I, xi, x, yi. Now we use this z function, xy. What I will do is I will do x times y, and then we push that into the empty product list. So product append x times y. If you print that, we already practiced that. And after we run this, we have our list of the product. So let's print product. So if I don't have, I think I have this product append can't multiply sequence by non-int of type list. So if I put here is the int. So here is, I think I give them is the int. Do I need to do like this? Let's not return first, because I don't have that. Print this find correlation. Oh. Let's not print, just call that. So just x times y. I think that should work. Cannot multiply sequence by non-int of type list. So that is the interesting part. So we gave our list, and then they're talking find this for x and y. Let's not go to this one, and we put this, come to here. Let's do the test. Same is product count x times y. So also I bet this should be the x is a list, so I should do this element level. Now I got this 5, 6, 5, 16, 6, 6 times 5, 30, and 12. Oh, yeah, that's perfect. So we can delete these debug lines. And then we have this list, and what we will do is the sum product x, y. Then that is just use our sum function. So we have this one. So now this is this one. Remember here we also need to times n. So later on we will calculate that. Don't forget about that n. And then we will do these two parts. So here you can see sum x is just a sum x. Sum y is just the sum y. So you can see in Python doing a list is quite easy. So and then squared sum x. So this is what we will put this here. So it just make every component is calculated. It's a sum x squares with 2 sigma sum x. Sum x is here. So I think it's this one. This one first. Then same is squared sum y is the sum x sum y square 2. So it's this part. And now let's do this part, because this part is we should have every element squares first. So that will be done by the loop. Then we have some new list. We call this x square list. We calculate this x square as our new list and then make that sum. So that is the logic. We put that as an empty list. And then we for xi in x. So we don't need a zip. We just need to calculate x square append with the x times square. Yeah, don't forget about here is the element level. Then find the sum is x squared. So here is a squared sum. Here is x squared sum. So square first, then sum second. So it's the sum x square. So same as we will put this to y. So let's just change y square for yi in y, and the y square is the yi, and here is the y, and here is y. Yeah. So now we have here, 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 and all the 4 parts, and we will combine them. Just ensure you don't forget about somewhere they have the n as the multiply. So now we have all the elements. So we will use formula to calculate correlation. So numerator, so upper one. That's not numerator. Ensure you have a right part is this n. Don't forget, and times product xy minus sum x times sum y. So that is our numerator, and we will have this denominator denominator is first part. N times this is the square. N times x square sum, and time minus squared sum x. So we will have this first part. That is the numerator we already have, and now is the denominator. So denominator terms 1. So first part is n times x squared sum minus squared sum x. So just to ensure you don't choose the wrong variable. So denominator term 2 is the second part is the n times y squared sum minus squared sum y. And then we have combine them is denominator is, don't forget about here we have a square root. So we have this denominator terms 1 times denominator term 2, and then squares with 0.5 means the square root. Then final of correlation is equal to the numerator divided by denominator. Yeah, we're done. Then we can return that. So print. The correlation of, let's see, this is x and this is y, the second is and 2, and with format, so you should be familiar with those quite well for our formatting print. So that is our, and you see here don't have the capital. Let's see, so it should get the correlation of this list and this list is minus 0.259, so that is too long. So let's give our .2f, that's enough. So that just 0.26. So it's closer to 0. So closer to 0 means they have almost, let's see. So what's the explanation? A correlation coefficient of 0 indicate there's no linear correlation. So that is the way. So let's give another side. So if I put is x is 1, 2, 3, 4, 5. Let's say y is just a double. So 2, 4, 6, 8, 10. So let's see what's the correlation for these two. Is perfectly 1.0. So if I have this base, let's see here. So you can see it's perfect minus 1. So if we put in that is in the plotting diagram or the chart, you can see that is one is on this the shape, another is this shape. So that is the correlation. So you can create some data set to help you with test what are those correlations means. And we will use this correlation formula to discuss some high school grade and the performance on college admission test in the next video. See you then. So hello, welcome back. It's last video we finished the first part of this correlation calculation. We built our the function, self function to do that. And for this second part of this sub-chapter, we will talking about is how you can use this function to deal with our high school grade and the performance of the college admission. The scores in this the correlation analysis. So it's this one, and then we will starting to use some actual the data site. So let's first we make our copy correlation. So let's see the second one, correlation. Just to do some analysis, correlation analysis. So we keep using our this correlation test for college. The admission test score with other factors. We will change the two factor. So first is we see here. So if you have these two parts, let's make sure is we have high school grades. So we have 90, 92, 95, 86, 87, 87, 90, 95, 98, 96. So these are representing 10 students high school grade, and then the college admission score. So first match to the first student. So that is the one-to-one match. Yeah, insure is also 10. So we can do the correlation of these two. So if the length high school is equal to length college, then we will let them to have this. Is a little longer, but that ensure is you don't make that mixed. So it's still running that, but what I want is if its length is the same, then I will do that. Else I will print this match on the data sets length. So we can do a test. If I have one more, just the difference. So if I try to run that, you will see this match on the data size length. So that is give you some hints. If I have that, I can calculate first and the second correlation is 0.32. So that is a very quick you get this one. So maybe so we can see here correlation of, let's make our here and let's make some shorter. So now correlation of this one and this one is 0.32. So 0.32 almost means there's some correlation, but not very strong. So let's do the second part. Is we will make this comment. The test so now we see the high school math, not the overall high school scores. So math is 33, 85, 84, 69, 96, 94, 60, 86, 87, 97, 97, 85. Now I replace this here, here, and here. So let's calculate again. So you get, is 1 point. Is this so perfect? So if I put in that, maybe I should have 5. Yeah, so 99896. So this you can find is almost 1.0. So this we can see have a very strong correlation. We can conclude that there's indeed a strong relationship in this data set between grade in high school math and performance on college admission. So that is the simple one. Is we want to show you is how you can make that. And then there, we next in the next video is we will have the way to show that into this scatter. So scatter table or scatter chart is our useful things to visualize this. Now we only have our number after calculate, and we will show that. And then this what's this 99896 difference to this this 0.32, how they distributed in the 2-dimension coordinated space. So see you in the next video. Bye for now.